Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the introduction to definite and indefinite integrals. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, assuming we have the function y, okay, and we are able to convert this function to what? Dy dx. Okay, we call this what? Differentiation. That is what? We differentiate the function with respect to what? With respect to what? X. Now, what happens if you want to go the reverse way? That is, we want to convert dy dx, okay, to what? The function y. We call this what? Integration. So simply put, integration is the reverse of what? Differentiation. Alright. Now there is a general way of what? Integrating a function. So assuming we have the function of the form ax power n, how do we integrate this function? Now we integrate the function by applying the sign big S to the function. Then we add what? The s to it. Okay, so what this means is that this sign, okay, means the integral of, okay, then the s means what? With respect to s. So it means we are integrating what we have over here with respect to s. Now, like I said, this is our integral sign, and then the function over here, okay, becomes what we call the integrand. The integrand. Okay, now this is what? With respect to what? X. Okay, so with respect to what? X, or any value or any variable that we have over here. Okay, and then this is our what? Our integral sign or symbol. Okay, so now if we integrate the function that looks like this, let's look at the general form. Okay, now if we integrate the function, all we do is what? We add 1 to the power or the exponent or the index of that function, and then we divide it by the new what? Power. So what I mean by this is, if we integrate this function, we are going to get what? Ax power n plus 1, all divided by what? N plus 1. Then we now add a constant to it. So it means to differentiate the function, all we need to do is what? Add 1 to the power and then divide that by what? The new power that we have over here, which is what is over here. Okay, now the c is called the constant of integration, or the arbitrary constant of what? Integration. Now the process of integration, where the constant of integration is not known, is what we call the indefinite integral. Okay, so this form of what? Integration, where we don't have any limit to the integration. So after we integrate, we need to add c, which is a constant, and we do not know the value of the constant. We call this what? Indefinite integration, or indefinite integral. Indefinite integral. Now let's have a look at an example of how to easily integrate. So if we have the function, we have to integrate what? 2x power 4 dx. Okay, so this is an example of what? An indefinite integral, and all we do is what? We say this is equal to, so to integrate this function, it means we add 1 to the power and then we divide it by what? The new power that we now have. So it will become what? 2x power 4 plus 1, all on what? 4 plus 1. Then we add a constant c, because it is what? An indefinite integral. So this becomes what? 2x power 5, all on 5 plus c as our answer, or if you like, you can bring it out 2 over 5 x power 5 plus c as the answer for our integration. Now let's have a look at another simple example. So we have to integrate root x with respect to what? X. Okay, so to integrate this, root x can be rewritten as what? X raised to the power half dx. Okay, so from here all we need to do is what? Add 1 to the power. Okay, and then we divide by what? The new power, and we add what? C to it. Now if we add 1 to half, that becomes what? 3 over 2. So we have x raised to the power 3 over 2 on what? 3 on 2 plus what? C. Okay, so if we rewrite all of this, we are going to get what? We bring this to the top, it becomes what? 2 over 3 multiplied by what? X raised to the power what? 3 on 2 plus what? Plus C as our answer. Now how do we integrate a constant? Okay, so integrating a constant. Okay, so assuming we have a constant, let's say integral of k, and k is our constant, and we are integrating it with respect to what? To x. All we do is what? We add x to the constant. So if we integrate a constant, it becomes what? Kx, then we add c to it. Okay, so for instance, if we are to integrate 7 dx, okay, 7 dx, if we integrate it, it becomes what? 7x plus c. The same way, if we are to integrate, let's say 9 dx, okay, because 9 is just a constant, if we integrate it, it becomes what? 9x, then we add what? C to it. Alright, now let's look at how we integrate a sum or difference of a function. So assuming we have the function of the form, the integral of what? A sum of functions, let's say sum and the difference of functions. So we have the function f of x plus another function g of s, then minus another function h of what? X. And we are what? Integrating with respect to what? With respect to x. How do we solve this? So this is what? We integrate each of the individual functions within this curly bracket individually, and we add all of them, and that becomes what? Our integral, or our integration of the entire function. So this becomes the integral of what? The function f of x with respect to x, plus then we apply the integration to the second function, which is what? Integral of what? G of x dx, then minus the sign over here is still here, integral of what? H of x dx. Okay, so this becomes our final integration for this particular example. Alright, so with this, let's have a look at an example. Alright, so the first example we want to look at is we are to integrate the function 3x plus 2s squared minus 5 dx. We can see that this is of the form this that I've given over here. So let's go ahead and look at what? How to integrate this. So this will be equal to the integral of the function 3x dx plus the integral of what? 2s squared dx, okay, minus the integral of what? 5 ds. Now the 3 over here is a constant, so we can bring it outside of the integral sign. So we have 3 integral of what? X what? Dx, plus we have 2 over here, so we can bring it out, 2 integral of what? S squared dx, then minus, this is just the normal constant, so we maintain it, to integral of what? 5 dx. Okay, so we have over here 3. Now if we integrate s, it means it has power of 1, so we add 1 to that power, and we divide all by what? The new power is 1 plus 1, then plus, this is 2 already here. If we integrate s squared, we add 1 to the power, and then we divide by what? The new power, then minus, we have what? Just a constant over here, so we add x to it. Okay, so it means we've differentiated everything we have over here to become this, so we add c to it. So it means our final answer after this will be what? 3 on 2 multiplied by what? S squared, plus we have 2 on 3 s cubed minus what? 5s plus c as our answer for this particular example. Now let's look at another example. Let me use another color for that illustration. So the second example we want to look at, example number 2, is if we are to integrate the function m cubed plus what? 3m squared minus 1 all over what? M squared, then dm. Okay, so it means we are integrating m with respect to what? M. Okay, so this becomes what? Before we integrate, we need to simplify what we have in the bracket. So we have the integral of what? This becomes m cubed on what? M squared plus this variable over here, 3m squared over what? M squared, then minus 1 over what? M squared dm. So this will cancel some of this, so we still have integral of 1. This will become m plus here will become 3 because this cancels this. Okay, then we have plus, minus, this is what? 1 over m squared. So if you bring m to the top, it becomes m raised to the power negative 2 dm. Okay, so from here we can integrate each of the variables separately. Now I can express this in the form this by applying the integration to each of them individually, and then I integrate, but that will waste time. But in case of exam, you need to do that for the teacher or the lecturer to see. But I'm going to be skipping this step and then jump all the way to this step at once. So it means from here, if I integrate m, I know I'm going to have what? Our m, it has power of 1. I add 1 to it, then I divide by what? The new power, which is 1 plus 1, then plus, this is a constant. I know if I integrate a constant, I add what? S to it, but in this case I'm using m, not s, so I add what? M to it, so it becomes what? 3m, then minus, I now have this m, this is the power negative 2, so it means I need to add 1 to the power and divide by what? The new power is negative 2 plus 1, then I add a constant c. So from here I can go ahead and have what? This is what? M squared over what? 2 plus what? 3m, then minus, this becomes m raised to the power negative 1 all divided by what? Negative 1, then plus c. So it means my final answer will be m squared over 2 is still 1 over 2m squared, then plus 3m. Then the negative here will cancel the negative here, so it becomes positive. So m inverse is just 1 raised to the power 1 divided by m, then plus c. So this is our answer after we integrate the function this. Okay, right. So now let's move to what? Definite integrals. Now, like I said, if you have a function of the form ax power n dx, okay, if we integrate this, it means we have ax power n plus 1 on what? N plus 1, then we add c, because what? There are no limits to this what? Integration, and this becomes what? Our indefinite integral. But now, what happens if we know the limit? That is, what happens if we say let's integrate from point A to point B? That is, if we want to integrate from, let's say, 3 to 1. Sorry, if we want to integrate from 1 to 3 of the function ax power n dx. So it means if we apply, these are what we call the limits. Okay, so it's limiting where we are to integrate from and where we are to stop. So we are integrating from 1 to what? 3. Okay, so it means all we need to do is what? If we integrate the function, we are going to have ax power n plus 1 on what? N plus 1. Then we now apply the limit to this. So we have 3, 1. So it means we need to express this in the form, wherever we see x, we put what 3 over there. So it means we are going to have something like this: a into brackets 3 raised to the power n plus 1 all over what n plus 1. That is for the first one. Then minus, we subtract the lower one from it, so that will be what a raised to the power 1 n plus 1 all over what n plus 1. Sorry, not a raised to the power. It is what a multiplied by what 1 raised to the power n plus 1 all over what n plus 1. So this is the format it goes. That is, we have a limit to the integral that we now have. That is, we are integrating from 1 to 3. And so after we do the integration, we apply the limits to it, and that is, we substitute the 3 over here, or the value at the top over here, in place of x. Then we do that calculation and we get the answer. That is what we have over here. Then we substitute 1 over there, we get that as well. So we subtract the lower one, the one at the bottom over here, from the one at the upper one over here, and that will give us what our answer for our definite integral. Alright, so with this in mind, let's have a look at an example. So let's look at this example. So we are to integrate from 3 to 1 the function 3x squared plus 2x plus 4 dx. Alright, so let's look at how we solve this problem. So we are to integrate from 3 to 1 the function 3x squared plus 2x plus 4 dx. Okay, so it means we are to integrate each of these functions individually. Now I need to apply the integration throughout all of them, and I solve, but I'm going to skip that step as usual. So I'm going to have, I know if I integrate 3x squared, I'm going to get 3x squared plus 1. Then I divide the power, I divide it by what? The new power, which is 2 plus 1. Then plus, I have 2x, so I know it to be 2x, 1 plus 1. That is, it already has a power of 1. I add 1 to it. Then I divide that by what? The new power, which is 1 plus 1. Then plus, if I integrate a constant, I know a constant, I need to add what? X to it, so it becomes what? 4x. Then I apply my limits 3 and 1 to this. So this is equal to, I have here 3x power 3 divided by 3 plus what? 2x squared divided by 2 plus what? 4x. Still applying what? The limits 3 and 1. So this will cancel this cancels this. It means my final equation is what? S cubed plus what? S squared plus 4x with the limit what? 3 and 1. So this becomes what? First of all, I substitute my 3 over here, so it becomes 3 cubed plus what? 3 squared plus 4 into brackets 3. Then minus, I now substitute 1 in place of x. So I have 1 cubed plus what? 1 squared plus 4 into bracket 1. Okay, so if I do that, I'm going to get 48 over here. Then minus, over here I'm going to get 6. So it means my final answer becomes what? 42. So if we integrate this function, the answer we get is what? 42. And this is an example of what? A definite integral, or this is how a definite integral looks like. Alright, so let's have a look at another example of a definite integral. So we have to integrate from negative 2 to 2 of the function s squared minus 2 and then 2x minus 1 dx. Alright, let's write down our solution. Now, if we look at this, we can see that we have two functions multiplying each other and we have to integrate it. Okay, so the first thing we need to do is to expand our function so that we have it in a linear form, so that you can be able to what? Apply our integration to each of the functions individually and then find our final integral. So it means this will be what? Integration from -2 to 2. Then I use s squared to multiply everything, so I'm going to have s squared multiplied by what? 2x minus 1. Then minus the -2 over here is over here. Then 2x minus 1. Okay, or what? Dx. So it is what? The integral from -2 to 2. Now if I use the s squared to multiply this, I'm going to get what? 2s cubed. Then minus this will give me s squared. Then minus this will give me what? 4x. Then this will give me plus what? 2. Okay, dx. So now that I have this, I can apply my integration to all of them, and then I find my answer. Okay. All right. So this is equal to, I know if I integrate this function 2s raised to the power 3, I'm going to get my 2x 3. Then I add 1 to it, and I divide by what? 3 plus 1. Then minus the s squared over I have over here to become s squared plus 1. Then over what? 2 plus 1. Then minus 4x. It has power of 1. I add another 1 to it, and I divide by 1 plus 1. Then plus what? 2 is a constant, so I add what? X to it. Then I apply the limits to from -2 to 2. Alright, so from here, what I get is what? I have 2x power 4 divided by 4 minus what? 2 cubed divided by 3 minus 4s squared divided by here becomes 2, then plus what? 2x. Still applying my limits from -2 to 2. Alright, so this is now equal to what? 2 on 4 will give me what? 1 over 2 x power 4 minus 1 over 3 s cubed. This will give me 2 go here, 2 times, so it will give me 2s squared plus what? 2x. Still applying my limits from what? -2 to 2. So what this means is we are going to substitute the value of 2 in place of x over here. So we have half 2 raised to the power 4 minus 1 over 3, 2 cubed minus 2 raised to the power 2 squared plus what? 2 raised to the power 2. Then minus, then I now substitute -2, so it will be half -2 raised to the power 4 minus 1 over 3 -2 cubed minus 2 into bracket -2 squared plus 2 into bracket what? -2. Alright, so if we solve everything that we have over here, we are going to get -8 on 3 plus 4, then minus everything at this side, we are going to get what? 8 on 3 minus 4. Alright, so if we simplify everything we have over here, we are going to get 8 on 3 as our final answer. So this is the answer we get if we integrate the function that we have over here, applying the limits to it. So thank you so much for watching. Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about integration by substitution of an indefinite integral. So we want to first of all start by looking at an example of how to solve an indefinite integral using the method of substitution. Alright, so the first example, I'm to integrate the function x, the root of 1 minus x squared dx. Alright, so this is the question and I'm to integrate it. So let me write down the solution. Now, because we have two functions, that is, the first function is x and then the second function is having a root sign, we need to find a way of simplifying this function so that we can integrate it easily. And one of the ways we do that is by using substitution. So for instance, to solve this question, we said let any variable at all, let's say u, be equal to what we have in the bracket over here, that is 1 minus what? S squared. Now after we use another variable, okay, to represent what we have over here, we differentiate it, okay. So if we differentiate u, we have x over here, so we differentiate u with respect to x. So we get, if we differentiate this, 1 is a constant, so we differentiate a constant, we get 0, so that is gone. If we differentiate negative s squared, it means we still have the negative, we bring the 2 here, then we subtract 1 from the power, so it becomes x power 1. So if we differentiate 1 minus s squared, we get negative 2x. Okay, so now that we differentiated this, we can see that we have the x over here. So let's make the x the subject over here. If we make the s the subject over here, we are going to get what? Du over negative 2x. Okay, so now we can rewrite everything over here as this, then root of, we say let 1 minus s squared be what? U. So we have u dx over here. Okay, but we said what? Let dx, okay, but we made the s the subject over here, so which is what? Du over what? Negative 2s. So if we substitute this back over here, we now have the integral of x root of what? U, okay, multiplied by the ds now will become what? Du over what? Negative 2x. Okay, so we can rewrite everything over here as, because they are all multiplying, okay, and no, multiplication is commutative. It means I can bring the negative 2 under this, so it will become what? I can rewrite everything here as what? X multiplied by what? Root u multiplied by what? Du, okay, all over what? Negative 2x. And I can write this as what? X over what? Negative 2x multiplied by what? Root u what? Du. This is still the same as this. Okay, so from here I can see that the x will cancel this. I'm left with what? 1 over negative 2, and that becomes a constant. Okay, so I have integral 1 over what? Negative 2 multiplied by the root of u du. So because this is a constant, let me bring it outside so that I just integrate what I have. So I have negative 1 over 2, the integral of what? U raised to the power half. The root of any number or value is the value raised to the power half, then du. So all we have to do from here is just what? Integrate the function u, and then we find our answer. So we have half. Okay, now if we integrate u, we have u power half, then we add 1 to it and we divide all by what? The new power, which is what? Half plus 1. Then we add c to it. Okay, all right, so it means we have negative half, okay, then into bracket. Now if we add 1 to half, we get u raised to the power 3 over 2 divided by what? 3 on 2, okay, plus c. Let me just write it like this. So I have half, okay, then if I bring the denominator here upward, it becomes what? Multiplied by 2 over 3 u 3 on 2 plus c. Okay, so these two will cancel this, so I have negative 1 over 3 u raised to the power 3 on 2 plus c. Okay, and I can rewrite this as negative 1 over 3, okay, the root of what? U cubed, okay, plus c. Okay, but remember we did substitution where we said let u be what? 1 minus what? S squared. So we substitute the u back, so we now have 1 over 3, negative 1 over 3, sorry, root of what? 1 minus what? S squared all cubed plus c as our answer for integrating the function s root 1 minus s squared ds. Alright, so let's have a look at another example. So the second example we want to look at is the integral of the function 2x minus 5 raised to the power 7 dx. So let's write down our solution. Now we can see that the function in the brackets 2x minus 5 is multiplying itself 7 times, okay, and if you want to expand that, it's going to be very long and very tedious. So we need to find a simpler way of integrating this particular example. So the most simplest way of doing this is by the method of substitution. So we say let the function in the bracket be u. Okay, so we have 2s minus 5. So we now differentiate the function. So if we differentiate u with respect to s, we get what? Du ds, and it becomes what? If we differentiate 2s, the power of the s here is 1. It multiplies the 2, we still have what? 2. Now we subtract 1 from the power, it becomes 0. So x raised to the power 0 is 1, so it's still 2. Now if we differentiate the 5 over here, it's a constant, so we get 0. So if we differentiate the function 2x minus 5, our du ds is just what? 2. Alright, so let's make ds the subject. If we make ds the subject, we get what? Du over 2 as our answer. Alright, now that we have this, let's go back and then what? Bring our equation back. So we have the integral of what? 2x minus 5 raised to the power 7 dx. We are saying, we said let 2s minus 5 be what? U. So we have the integral of what? U power 7 dx. But remember, we say what? Or remember, we made ds the subject over here, where we are saying ds is equal to what? Du on 2. So if we substitute ds in place of this over here, we now have the integral of u power 7 what? Multiplied by what? Du on 2. Okay, so this can become the integral of what? This is on 2, so we can do that as half multiplied by u power 7 what? Du. Because this is a constant, we bring it outside the integration sign, so we have half the integral of u power 7 what? Du. So we have half. If we integrate u raised to the power 7, we have u power 7. We add 1 and then we divide by the new power that we have, which is 7 plus 1. Then we add the constant c, because we don't have limits to the integration, so it is an indefinite integral and we need to add the constant c. Alright, so from here we have half raised into bracket, then we have u power 8 on 8, okay, plus c. Alright, so from here we can see that we have half multiplied by u on 8. U raised to the power 8 on 8 can be rewritten as what? 1 over 8 multiplied by u power 8 plus c. So if we multiply these two fractions, we get what? 1 over 16 u power 8 plus c. Okay, but remember we said what? U is equal to what? 2s minus 5. So it means we have 1 over 16, okay, into bracket 2x minus 5 raised to the power 8 plus c as our answer for integrating the function 2x minus 5 all raised to the power 7 dx. Right, let's have a look at one final example. Alright, so example number 3, we have to integrate the function 2s on the root of 4s squared minus 1 dx. Alright, so looking at this question, we know we cannot integrate directly, so we need to use what? The method of substitution. So as usual, we say what? Let u be the function we have at the denominator over here, that is 4s squared minus 1. If we differentiate the function, we get du ds to be equal to the 2 multiplied by 4, we get 8x. This is a constant. We differentiate a constant, it becomes 0. So we make ds the subject over here, we get what? Du on what? 8x. So we can rewrite this whole integration as what? The integral of what? 2x on what? The root of u dx. But we made dx the subject and we said it is equal to what? Du on what? 8x. So if we substitute this in place of this, we get what? The integral of 2x on root of what? U multiplied by our ds is now what? Du on what? 8s. Now from simple mathematics, I can rewrite everything over here as what? 2x on 8x multiplied by what? Root u. Okay, sorry, I bring this over here, so multiplied by what? Du on root u. That is what I bring the, let me use another color to indicate that, which means I brought the 8s, okay, over here, and I brought the root of what? U in place of this. Okay, so I just switched their position, but it is still the same. Alright, so from here we have what? The integral of, we know s will cancel this. Here will go here 1, it will go here what? 4. So we have 1 over 4 what? Du on what? Root of what? U. So if we bring the 1 outside, we have 1 over 4 integral of what? This can be rewritten as 1 over what? Root of u du. Okay, alright, so we have 1 over 4 integral of what? U. Let's write it in a linear form. So if we bring the u to the top, it will become u raised to the power negative half. Root u is u raised to the power half, but because it is inverse and we want to write it in a linear form, if we send it up, it will become what? Negative half, then du. So from here we can go ahead and integrate to get our answer. Let me use black so that you can see clearly. I'm not too sure if you can see with this color that I've picked. So we have 1 over 4. This is equal to, we have 1 over 4. If we integrate u raised to the power negative half, we add 1 to it, and we divide by what? The new power, which is what? Half plus 1. Then we add c to it. So we have 1 over 4. Then we have this becomes what? U power half on what? On half plus c. So this is equal to 1 over 4, and we have u power half. If I bring this to the top, it becomes 2, okay, then plus c. So I can say that 1 over 4 multiplied by 2, we know the 2 going to itself 1, it will go here 2. So we have 1 over 2 u raised to the power half plus c. But remember, we said u is equal to what? 4s squared minus 1. So if we substitute that back, we have half, then into bracket 4s squared minus 1 raised to the power half plus c. And we can finally write this as 1 over 2, the root of what? 4s squared minus 1 plus c as our answer for integrating this function. So thank you so much for watching. Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the integration by substitution for a definite integral. So let's start with an example of how to integrate using the method of substitution for a definite integral. So we are to integrate the function from 0 to 2 of what? 3x on root of what? 2x squared plus 1 dx. So this is our question and we are to integrate it. So let's have a look at how we go to how we solve this example. So we write solution. Right, so the first thing we need to do is that we can integrate the function the way it is. So we need to express it in a more familiar or in a more linear way so that we can be able to solve it. So to do that, we need to use the method of substitution. By the method of substitution, the first thing we do is we say let the function u, 2x squared plus 1 be the function u. So we are saying let u be what? 2x squared plus 1. So now that we've said u to be that, okay, we now differentiate the function. So du dx, because we are differentiating with respect to x over here, so it becomes what? Du ds. So if we differentiate that, we know we use the power to multiply the coefficient, it becomes 4x. Then we subtract 1 from the power, so we have 4x. Now if we differentiate 1, it's a constant, so we get 0. So the differential of the equation 2x squared plus 1 becomes what? 4x. Now let's make the x the subject. So if we make the s the subject, we have du on 4x. Okay, Okay, so now that we have this, we can rewrite the entire equation as the integral of 2 to 0, from 0 to 2, sorry, of what 3x on the root of what u dx. Okay, so from here we can see, but dx, we made dx the subject and we said it is what du on 4x. So if we substitute that, we have the integral of what 0 to 2 3x on what the root of u multiplied by what du on what 4x. So we can write this as this. Okay, I can bring the 4 here, 4x over here, so I have 3x on what 4x multiplied by what du on what root of u. So this cancels this, so we have 3 on 4, which is a constant, so we can bring it outside. So we have 3 on 4 integral from 0 to 2 of the function. This can be rewritten as what 1 over what root u du. Now we can see that we now have the function in terms of what u and du, and no longer x dx. Okay, but the limits are still the same for that of what, as if they are still an x. So we need to change the limits. Change the limits. Okay, so if we are doing integration of what a definite integral, and we are using the method of substitution, after we do the substitution, we need to change the limits. Okay, so by changing the limit, we know that we said u to be equal to what 2s squared plus 1. So when u is 2 over here, then we have the limits to be what 2 multiplied by 2 squared plus 1, and that will give me 2 squared is 4 multiplied by 2 is 8 plus 1, that is 9. Okay, so the second one, we have u when it is 0 over here, the limit here, so we have 2 into bracket 0 squared plus 1, and this gives us 1. So it means our entire integral now becomes what 3 on 4. This becomes 3 on 4, the integral from what 1 to 9 of the function 1 over what root of u du. So from here we can go ahead and solve or integrate this function, and we get our answer. So we have 3 on 4 integral of what 9 from 1 to 9 on what, let me make this in a more linear way. So I have u, the root means it's a power of what half, but because it is 1 over root u, it becomes what negative then du. So I have 3 on 4. Now if I integrate this, I have what u negative half plus 1 on what negative half plus 1. Okay, because it is a definite integral, I don't need to add a constant, but what I need to bring the limits over here. So I have 3 on 4. Okay, then I have u power half on what half, the limits 1 to 9. Alright, so from here all I need to do, okay, is write 3 on 4. Then I bring 9 here, 9 raised to the power half divided by half, okay, minus, then I substitute 1, so it will be 1 power half on what half. Okay, so this will be equal to 3 on 4. Okay, now the entire of this, okay, 9 raised to the power half divided by 1 over 2 will give me what 6, and this will give me what 2. Okay, so if I multiply everything over here, I'm going to get the answer to be what 3. So it means if I integrate the definite integral, what integral from 0 to 2 of the function 3x over what the root of 2x squared plus 1 dx, the answer I get for this is 3. Alright, let's have a look at another example so that we further understand what we are talking about. So example number 2, we have to integrate from 1 to 3 of the function fx root of what 2s squared plus 7 dx. So let's write down our solution. So looking at this integration, straight away we know we need to use the method of substitution to solve it. So we say let the function that we have over here be u. So we have 2s squared plus 7. So if we differentiate u with respect to s, we get the u ds, and that will give us what? 4x. That is, we differentiate this. If we make the s the subject, we have what? The u on what? 4x. Okay, so we rewrite the integration. We have integral from 1 to 3, 5x, then root u dx. But we are saying the s is what? The u on what? 4x. So we have the integral of what? 1 to 3, 5x root of u multiplied by what? Du on what? 4x. That means we have the integral from 1 to 3 of what? This can be rewritten as what? 5x on 4x multiplied by what? Root u du. Okay, so the x will cancel this, so I'll bring them out. I have 5 on 4, the integral of what? 1 to 3 of what? Root u du. Alright, so now that I have this, okay, I need to what? Change my limits. Okay, change the limits, because I'm dealing with what? A definite integral, and I'm using the method of what? Substitution. So I said let u be what? 2s squared plus 7. So if u is equal to 3, I have 2 into brackets 3 squared plus 7, and that will give me a value of what? 25. So if u is equal to 1, I have 2 into bracket 1 squared plus 7, and that will give me a value of 9. So it means I am to integrate the function 5 on 4, the integral from what? 9 to 25 of the function u power half, which is still u root u, then du. Okay, so from here I can move ahead and find my answer. So I have 5 on 4. Then if I integrate this, I have u power half plus 1 on the power half plus 1. Okay, then 25 and 9. Alright, so this becomes 5 on 4. Then I have u raised to the power 3 on 2. Okay, and if I divided by what? 3 on 2, 25 and 9. So let me bring this up. So I have 5 on 4 into brackets 2 on 3, u raised to the power 3 on 2 for 25 and 9. So let's go ahead and simplify. So we have 5 on 4, then we have 2 on 3. When u is 25, we have this 3 on 2 minus 2 on 3. Then we substitute the value 9 here. We have 9 raised to the power 3 on 2. So we have 5 on 4. And if we compute this in our calculator, we are going to get 83.333 recurring. Then we subtract. If we input everything here into the calculator, we are getting what? 18. So if we multiply everything over here, we are going to get a final answer. That is, we subtract 18 from 83.33 and we multiply by the ratio 5 on 4. We are going to get what? 81.66625, which approximately, if you want to write it as an improper fraction, we have what? 81 whole number 2 on 3, not point. So it's 81 whole number 2 on 3. So this is 81.66625. So this is our answer. 81 whole number 2 on 3 is our answer if we integrate the definite integral this. Alright, let's have a look at what one final beautiful example, and then we end this tutorial. Alright, so example number 3, we want to integrate the function from 0 to 2 x into bracket x squared plus 1 raised to the power 3 dx. Now we've solved 2 examples already, so if you are confident enough you can tackle this question, please go ahead. Make sure you pause the video, you go ahead, you finish solving, and then when you're done you can play the video so that you watch me solve, and then you compare your answer at the end to see if you've really understood the first two examples that I gave. Alright, so welcome back, provided you pause the video and went to learn or went to solve the question. Sorry. So we have solution. So first of all, we say what, let u be what, s squared plus 1. So if we differentiate u with respect to s, we are going to get what, 2x. So as usual, we make the s the subject, we get what, du on what, 2x. Alright, so now that we have, this is x. Right, so now that we have this, we can write our integral as what, 2 this x into bracket what, u raised to the power 3 dx. Okay, so this is what, x u cube multiplied by what, du on what, 2x. Okay, so from here we have the integral from 0 to 2. I can write this as what, this whole thing as what, x on what, 2x multiplied by u cube what, du. Okay, so the x will cancel this, it means I have half over it, so I'll bring the half outside. The integral of 2 0 u power 3 what, du. Now what I need to do from here is to what, change my limits, change the limits. Okay, so by changing the limits, I know my u is equal to what, s squared plus 1. So if my u is equal to 2, I have what, I have 2 squared plus 1, and this is equal to 5. If my u is 0, I have what, 0 squared plus 1, and this is equal to 1. So I am to integrate I'm to integrate half the integral from 1 to 5 u cubed what, du. Alright, so from here I know I have half. Then if I integrate the function u cubed, I get u raised to the power 3 plus 1 on what, 3 plus 1. Okay, then I apply the limit that is from 1 to 5. Okay, so I have half, then this becomes u power 4 on 4 from what, 1 to 5. So this becomes half. Then I have 5 raised to the power 4 on 4 minus, then I have 1 over here raised to the power 5 on 4. Okay, so I have half. If I compute this in the calculator, I'm going to get 156.25, then minus this will give me what, 0.25. So that becomes half of what, 156, and this is equal to what, 78. So this is the answer we are expected to obtain if we integrate the definite integral of this by the method of substitution. So thank you so much for watching, and I will see you in the next video. Bye bye.